Good day everyone, this is a video presentation for the 37 EECE Thesis Colloquium. I am RENZ DENISE CALANGI from the Computer Engineering Program to present to you our thesis, which is entitled Area and Color Severity Detection of Measles. Measles, or also called as rubiola, is an infection in the respiratory system caused by rubiola virus. Measles is a very contagious disease that can be transmitted through coughing and sneezing, close personal contact, or direct contact with the infected nasal or throat secretion. Measles still kills more than 100,000 people a year worldwide, mostly under the age of 5. Measles is a highly infectious illness caused by the virus called a paramyxovirus. Existing measles detection is based on the examination of the doctor on its symptoms or by running some blood tests. There are a few studies that use image processing on skin image and support vector machine for classification. The general objective of this study is to detect the severity of measles based on the area and color using image processing algorithm and support vector machine. Specifically, the study aims to create a device that will detect measles through image processing using Raspberry Pi. Next is to determine the severity of measles based on the area and color using support vector machine and image processing algorithms. Last is to verify if the detection and the phase of severity is correct compared to the doctor's evaluation. The device will not be able to classify or categorize the other type of skin disease occurred and what caused it. The study will use image processing technique like color detection using HSV color space, image masking, image binary, pixel count, and the use of support vector machine to detect the rash if it is measles. The study will be using Raspberry Pi 3 microcomputer for the implementation of the device and support vector machine learning technique for processing the detection of measles. The study will be using Python language. For the conceptual framework, the captured image will be the input for the system. The system will use some image processing techniques to process the captured image and detect measles. The techniques used are HSV color space conversion, image binary, image masking, and support vector machine. The system will display if the rash is a measles or not, and if it is measles, it displays its severity based on color, area, and color. So for the hardware block diagram, the Raspberry Pi 3 is the microcomputer that processes the image captured and applies the image processing algorithm to obtain the results. The camera module will capture the image, and the output will be displayed in the LCD. The power supply provides power for the Raspberry Pi, and the Raspberry Pi provides power to the camera module and the LCD. For our main system flowchart, the capture image will be processed using image processing technique to detect if the rash is measles. The image is processed to detect if it is measles, and if it is classified as measles, the system will measure its severity in color and area. The results is then displayed in the LCD. For our measles detection module flowchart, the input image is used in SVM-based feature detection algorithm that is developed from the feature map from the training process. For our severity analyzation based on area of the rash module flowchart, the input image is converted to HSV color space and image masking to segment the red rash from the skin. The process is done again to segment the color of the skin from the rash. The ratio is computed after having the pixel count for the skin and the rash. To get the ratio of the area of the rash to the skin, the formula is used as ratio of rash in skin is equivalent number of red pixels over the total number of red and brown pixels. For the severity analyzation based on color of the rash module flowchart, the input image is converted to HSV color space and compute for the average value of the HSV value of the rash. So the relationship of severity, here's our table which has the severity of measles based on area, which is identified as light, moderate, and severe. And then for the ratio of the measles pixels to skin pixels, for light, 2.82% to 20.41%. while for the moderate, 20.41% to 35.03%, and then for the severe, 35.03% and above. For the data gathering procedures, the experiment will be conducted during the rash is visible in the patient. The doctor will observe the rash if it is rubiola, measles, and identify its phase of maturity. The components will be used are camera module, LCD display, and Raspberry Pi 3 microcomputer. The area of the rash will be placed under the device and make sure that the camera will have a clear image of the rash. The camera will get a picture of the skin with rash and image will be sent to the microcomputer for processing.
Good day. I am Ian Gabriel Bautista. To continue with the presentation, here are the steps for the image processing techniques used for the data gathering. First, the Raspberry Pi 3 will read the input image captured by Raspberry Pi camera version 2. Next, convert the image to its HSV color space value to count for the number of pixels that has rashes. The left image is the input image captured from the camera. The right image is the output image after converting to HSV color space. The number of pixels that is covered with Rash is 147,675. Next, apply image masking for the Rash. The left image is the input image. The right image is the output image after applying image masking for Rash. Next, convert the image to its HSV color space value to count for the number of pixels covered by skin. The left image is the input image and the right image is the output image after converting to HSV color space. The number of pixels that is covered by skin is 225,123. Next, apply image masking for the skin. The left image is the input image. The right image is the output image after applying image masking for the skin. Next, apply AND-bit operator or the bitwise operator to combine the two images of the skin and the rash after image masking. The total number of pixels of rash and skin is 225,218. Next, compute for the area ratio of rash in skin using the formula number of pixels of rash divided by the total number of pixels of rash and skin. Using the previous image, the area ratio is 65.57%. Then next, get the average value of the red HSV value to get the average redness of the rash. The average ratio we got is 2.82% to 20.41% for light severity and 20.42% to 35.0.3% area ratio for moderate severity and 35.04% and above for severe measles. Table 3.9 is the testing table used for the measles detection. We test 10 patients that is evaluated by doctors and the device. The device evaluation is compared to the doctor's evaluation for testing the performance of the device. The device correctly classified patients A, B, C, D, and E for measles as measles, and patients F, I, and J with not measles. The device incorrectly classified patients G and H. The device classified the rash with measles, but it is not measles. Table 3.10 is the testing table used for the determination of severity of the area of the rash. We also used the same 10 patients and evaluated by the doctor the device. The device evaluation of severity is compared to doctor's evaluation for testing the performance of the device in determination of severity. The device correctly classified the severity of patients A, B, C, D, E, F, I, and J as the correct severity. The device incorrectly classified the severity of patients G and H. Patient G and H are not measles, but the device evaluated it as measles with 19.06% and 16.66% area ratio. Table 3.11 is the confusion matrix used for the testing table number 3.9 for measles detection. The left part of the device is the evaluation side, and the upper part is the doctor's evaluation. It is classified as unknown skin disease and measles. The device correctly classified 3 unknown skin diseases and 5 measles. The device incorrectly classified 2 unknown measles as measles. To compute for the accuracy of the device on determining measles rash, we use the formula true positive plus true negative all over true positive plus true negative plus false positive plus false negative times 100%. The accuracy of the device in determining measles rash is 80%. Table 3.12 is the confusion matrix used for the testing table number 3.10 for measles severity detection. The left part is the device evaluation and the upper part is the doctor's evaluation. It is classified as light severity, moderate severity, severe measles, and not measles. The device correctly classified 1 light, 1 moderate, 3 severe, and 3 not measles. The device incorrectly classified 2 not measles as light severity measles. The accuracy of the device on determining measles severity detection, we use the formula true light plus true moderate plus true severe plus true not measles all over true light, moderate, severe, and not measles plus false light, moderate, severe, and not measles times 100%. The accuracy of the device in determining measles severity detection is 80%. For the conclusion, the researchers were able to construct a device that detects measles from the captured images. The device can classify the severity of the measles based on its area and color. The use of image processing techniques such as HSV color space conversion, image masking, image binary conversion, and the support vector machine for the feature extraction of the image of the measles are reliable to use as detection of measles rash. The researchers recommend for the improvement of the device would require to use a different machine learning such as convolutional neural network for an automatic feature extraction since we use the manual training method to train the device. For the hardware, cameras with higher resolution may be applied for newer feature. Medical field courses may also pair up with engineering courses for an accurate result. Thank you for listening. That ends our presentation on our thesis entitled Area and Color Severity Detection of Measles.